welcome as well from my side to all of you. Well, as you already see, today's talk going to be about Postgres. It's also going to be about analytics and how this goes along. But before diving into the technical details, a few words on myself. So I'm co-founder of the company Benchant, which is actually a spin-off of the Ulm University in Germany. So I have an academic background, did a lot of work in distributed systems research, cloud computing research, and also database systems. And for now 4 years, we're running the company Benchant, which is specialized in running technical performance benchmarks for any kind of database systems and other distributed systems. But enough of myself, so let's dive right into the topic of today. Over the last, let's say, 5 to 10 years, we saw that Postgres gained tremendous momentum when it comes to handle OLTP workloads and even bring back workloads from other domains such as NoSQL databases back to the relational domain to Postgres. And over the last 1 to 2 years, we also saw quite some, well, let's say, news, noise, innovations around Postgres and analytics. Especially when you Google Postgres and analytics, you might come across one or all of these headlines, where major analytics providers acquired or partnered with Postgres companies. And now let's have a brief look what that means on a technical level. So here you're going to see on the left side the Databricks architecture with the Delta Lake, Lake-based for Postgres, in the middle Snowflake and Postgres, and to the right ClickHouse. I won't go into details of these architectures today. That's going to be a completely different talk, but just want to highlight how they treat Postgres and how that fits into the stack. So we see that Postgres in this respect is still used to handle the OLTP workloads. And data is synced by CDC, mechanisms, batch, ETL, and so on to the analytical platforms to handle the actual OLAP workloads. So what we're actually going to dive into today is more into, well, can we use just Postgres to run analytical workloads? And how far going to bring us this in the context of the whole analytical workloads and the native providers. And before diving into more details in that respect, a few words on what is an analytical workload these days. In traditional context, it was data warehousing, business intelligence, but nowadays we see a lot more in that, or it gets way more heterogeneous. So we have, of course, ad hoc analytics, dashboard analytics, up to petabyte analytical workloads. We got search. We also might have agentic workloads that are considered as analytical. That's still quite evolving. But what we have as a common ground is that we usually talk about disk-bound workloads of large data set, whatever means large, but gonna be disk-bound workloads. We have different kind of schemas that are used. So OLTP, usually normalized schema. So for OLAP, we got star schema, snowflake schema, or fully denormalized data. The queries are typically complex, multiple joins, aggregations, groupings, and so on. And the access pattern is usually read-dominated with some batch stream inserts. Updates are rather unusual in that domain. So this just as having as a common understanding on an analytical workload. So can we now turn Postgres into an analytical database? This is what we're going to have a closer look for today. And well, the Postgres ecosystem, as you probably know, it's really powerful, it's really innovative, and there are a multitude of extensions to handle basically every kind of database workload you can think of. You're going to find one or multiple extensions. So, for instance, for the analytical domain, we did a brief research, and it was easy to already find over 20 extensions that address analytical workloads in Postgres by very heterogeneous approaches, adding a columnar storage engine, adding a dedicated query engine for analytical workloads, adding both, using GPUs and other kind of stuff. So the ecosystem is quite powerful. And I will just briefly talk about 3 extensions. So you might have heard of the Citues extension. So they're formerly known for adding a distribution support to Postgres, so making it a distributed database systems by distributed tables, distributed query engines, but they also add support for a columnar storage engine, which was formerly the CStore FDW extension. This is now part of the Citues project. That already promises to provide significant improvements for analytical workloads, and of course it also can be combined with the whole distributed setup. A second one is the TimescaleDB extension. This one is maintained by, well, TimescaleDB is now, the company behind it is now TigerData, so they renamed. These are formerly known for handling time series workloads, but they also add a columnar storage engine to Postgres for improving data compression, improving vectorized query performance. And they basically address the real-time analytics workload domain. And the probably most recent extension in that context is the PG DuckDB extension. So this allows you to embed DuckDB into Postgres. So for all of you who are not familiar with DuckDB, it's basically a lightweight embedded database for columnar and vectorized query execution to speed up these kind of queries. And there's also going to be a talk tomorrow that goes way more in detail about DuckDB. So the main features of this extension is basically, well, improving performance for the analytical queries, and it promises to, or it shows that this can be done without minimal or without any changes to your current application. Just turn on the engine and that's it. In a more technical level, I brought here a small code snippet that shows how you can use it. After installing the extension to your Postgres, you just set the execution and that's it. You're gonna get a speed up of your analytical queries, hopefully. Apart from that, of course, there's more to the extension. You can also use it to read, write to data lakes, such as, well, Iceberg, S3, Parquet tables, and many more. And you can use it to have a direct, or you can directly integrate it with the MotherDuck Cloud Analytics platform, which again would fit the architecture I've shown in the beginning, where you have a dedicated analytical engine to run the analytical queries. So this is the extension we chose for today to get a bit more into detail, and especially as we're a company that is focusing on performance benchmarks, I brought some performance numbers where we compare the performance or have a look at the performance gains you can get with that extension. So there are basically three objectives that I brought for the performance numbers for today. The first one, maybe a bit bold one, let's see if that extension allows us to push the performance of Postgres with this extension to the ClickHouse level. But we also want to see how these extensions compete with in the context of two specific analytical workloads, so the ones from these two domains, data warehousing, BI, and the other dashboard or ad hoc analytics. And of course, we want to see what is the performance gain over a native Postgres database. So before diving into the actual numbers, of course, you need some kind of a background on the setup, as it is always the case for benchmarks. Just briefly, we deployed Postgres on AWS EC2 instances. For ClickHouse, we used ClickHouse Cloud. Of course, that's not an apple-to-apple comparison, but we want to set the bar as high as possible when we do the ClickHouse comparison. We have all the data, the whole data set is open source at that GitHub link. So if you want to dive into all the applied configuration, knobs and bolts, the raw results, you're going to find it there. As a side note, we also did not use the default Postgres configuration. We applied, let's say, a basic tuning for an analytical workload. The first benchmark that we used is the ClickBench. This is maintained and published by ClickHouse, so it's their playing field, just to keep that in mind. We used all the official schemas index definitions. The only thing that we, well, not changed, but we applied the benchmark execution methodology in our bench-end platform that is able to automatically set up databases on every cloud provider or any dbus to orchestrate the benchmark execution and collect all the results, metadata, monitoring data, and so on. This is the only change that we made. A few words on the dataset. It's a flat table with 104 columns, so don't expect joins on this dataset. But there are 43 different analytical queries with static values. And the ClickBench methodology emphasizes a single-threaded execution. So this is also what we used. And we only did one iteration per query, so they're actually cold runs. So enough of the background. Let's see some numbers. So here you're going to see the query latency per query over the 43 queries. The blue bar is the ClickHouse latency. You might see it or don't see it, maybe here. So in a nutshell, you would also see it here if I would have picked a different scale, but ClickHouse is super fast. The orange one is the PG DuckDB extension with Postgres, and the green one is the plain Postgres. So coming to the first question that we had, we probably not be able to push it to ClickHouse level, but this might also be a bit too optimistic by just adding an extension, turning it on, and we would achieve ClickHouse level performance with their huge engineering team. So the probably more accurate question is, well, where does it actually benefit from adding or using this extension over a native Postgres? And there we used these results, split it in 3 categories based on their runtime. And we see for the upper level, these are the shorter running queries. Here, well, PGDuckDB only wins for 2 cases, but Postgres wins for 9. But when we go to the longer running queries, we see that there are wins by adding just PGDuckDB. And if we want to see that, let's say in more in numbers, we see there can be performance improvements even for the shorter runnings up to 7 times. For the others up to 2 or 3 times, but there can be also severe regressions on the performance for some queries if we use that kind of extension. Well, if you look into the queries in detail, this won't be such a surprising thing, as some do just single point select based on some filtering first, where an index is put on top. Due to the time constraint, I can't go into the query details in the queries and query plans right now. But what I wanted to show is also for a second use case. So we also used the TPCDS, the well-known data warehouse benchmark, where we used a comparably small data set of only 10 gigabyte. The data set here, it's 24 tables in a Snowflake schema. So here, we definitely gonna have joins. And the TPCDS original spec comes with 99 queries. We just picked 10, where we think this is are the most beneficial for this extension, as they have multi-weight joins, aggregations, and grouping. Again, single-threaded query execution. The only change here is that we did 1,000 iterations per query and report the P95 latency numbers. Here we already see it's kind of different picture. You're gonna see the ClickHouse bars. Of course, again, this is probably not the data model that you're gonna use when you use ClickHouse with that many joins involved. It's also just as a very first baseline to show here. In the end, ClickHouse still wins in 4 cases, but we see with PGDuckDB wins in 2 cases and Postgres in 1. And we have 3 draws where it's more or less in the same area, the latency. If we look again more from the PGDuckDB perspective on the numbers, improvement here is nearly up to 3 times, but we also have, in the worst case, a regression of roughly two times. So these are the numbers I brought today to give a very, very baseline overview on what can you get with that extension. You probably going to think now, okay, but we skipped a lot. Of course, due to the time, we can't go in all of these details, even if they would be really interesting. This is something that we with Benchen going to follow up and also publish some blog posts on these topics in more detail. So I will, in the end, I will show you, if you're interested in that, how to get access to this. But let's wrap it up by coming back to the initial question. So is Postgres actually eating analytics too? Just based on these numbers, you would think probably no, but of course there are tiny snapshot of the overall picture. So what we actually see is that Postgres is definitely expanding beyond OLTP. There are a very heterogeneous field of extensions to Postgres in different maturity states that all address the analytical use cases, or several of them. The extension that we use today already shows some promising results, but also mixed results. But given to its simplicity, it's interesting that the performance improvements are already really promising. And we not yet use the really cool features, such as including the analytics engine of MotherDuck, for instance. And well, we with Benchen going to follow up that road, running more performance studies and publishing these results as well on our blog and our newsletter. So I hope that I got you an overview and got you interested in the topic. If you want to hear more about the performance data or more in-depth details, I'm happy to catch up questions afterward. I will be around, and feel also free to connect on LinkedIn or subscribe to our newsletter where you get new blog posts on these topics in the upcoming month. Thank you.
Thank you very much, Daniel, for that insightful talk. We have time for like 1 or 2 short questions. Yes, I see a hand over there. Let me bring you the microphone real quick.
Cheers. Hi. A quick question, because I didn't understand. Is all of the data in Postgres, or is it some of it in MotherDuck?
No, it's all in Postgres. They're plain Postgres tables. So for the results with the Postgres native and Postgres PGDuckDB extension, it's basically your application. You didn't change anything to the data, didn't export it somewhere, just have it in Postgres. Yeah.
All right. Thank you very much. Give it up again for Daniel.